All right, question 6 from last year is a straightforward calculus problem. This problem doesn't have any word problem associated with it. It's not tying it to anything real world. It's simply just here's some functions. Let's see how much calculus you know. I can almost with 100% certainty guarantee that one of the 3 questions that they're going to give you this year is going to be something like this. Just a straightforward calculus. When we look at all the stuff that we're going to be doing throughout here, taking derivatives, potentially integrating, doing limits, all that stuff, it's straightforward. It's do you know your stuff or don't you know your stuff? If I were to study one problem from last year's test, this is the problem I would make sure I know forwards and backwards, except for part D, and we'll talk about part D when we get there. So first, part A, or before we get to part A, the actual problem, we have G and H. We know their values. G and H at 2 are equal to 4. We have a tangent line for both G and H, and then they also talk about this function f. We'll get to function f in a bit. So part A is simply asking us to find h prime of 2. Okay, no problem. H prime would just be the derivative of h, but I don't have the function h. But I do know that the tangent line to h is the line y equals 4 plus 2/3 x minus 2. That line has a slope that's equal to 2/3. Hopefully we can clearly see that. I don't need to go through and put into y equals mx plus b to figure that out. Well, if that slope is 2/3 and h prime is the slope, there it is. I just did part A. Now, it's not a lot of points. That is going to give you, you're right, 1 solid point. But that's a point we should all have. If you know what's up with calculus, you know what a derivative gives you, they can't possibly ask you anything easier. Part A, if you've noticed, if you look back at all 6 problems, Part A usually is something like this. It's usually very straightforward. There was one Part A that was very long, but for the rest of the problems, Part A was usually, here, do something very quickly. That's usually how it goes. Part A is very slowly work into the problem. Part B is, all right, it's not too bad. Then they hammer you over the head with Part C and Part D, right? Be prepared for that. That's usually the case. Part A and Part B are usually easier than Part C and or Part D. So as you work through this test, keep that in mind. Part B, we have a new function, a of x, and they're telling us in Part B that a of x, I don't know why they use a lowercase, well, we use lowercases for the others, but a of x is equal to 3x cubed times h of x. Okay, no problem. We want to find a prime, and then we want to evaluate a prime at 2. All right, well, again, this is just straightforward calculus. If we look, especially the way that I wrote it, it's 3x cubed times h of x. That means I got to do the product rule. So the product rule, I'll take my first term, 3x cubed, and I'll multiply by the derivative of h, which is h prime, plus I'll take h of x, and then multiply by the derivative of 3x cubed, and the derivative of 3x cubed is 9x squared. Pretty straightforward. There's a prime. That's it. You don't have to clean that up. There's nothing to clean up. You don't have to manipulate it. Don't. Just leave it just like that. And then the next part we're asked to do is we're asked to find a prime evaluated at 2. And so we know that means just to plug in 2. So this is going to be 3 times 2 cubed times h prime of 2. It's a good thing we did Part A. Plus h of 2 times 9 times 2 squared. So if we go through and work that out, we have 3 times 2 cubed. Well, 2 cubed is 8. 8 times 3 is 24. And then times h prime of 2, we just did that in Part A. Part A asked us to find h prime of 2. It's 2/3. So we can simply take this and multiply it by 2/3. Plus h of 2, well, if we go back to the original problem, h of 2 is 4. And so we put a 4 there. 9 times 2 squared is 36. 2 squared is 4 times 9 is 36. And then if you multiply those together and add it all up, you should end up getting 160. Not too bad, even though you don't have a calculator, that's still pretty doable. If we look at points for this one, you actually get 3 points for this problem. You get 1 point for recognizing that you have to do the product rule. So even if you have the product rule incorrect, you at least get a point if it looks like you tried to do the product rule. You get a point for plugging in the values, specifically coming up with h prime and h of 2. That's really what they're going to look for, and then 1 point for your correct answer. That's 3 points we got to have, and if we look out of Part A and Part B, that's 50%. The way it used to be, and I'm not sure how they're grading it this year, but 50% would get you passing this test, and right now, you should all be passing this. This is super duper easy. It's just straightforward calculus. Part C is also straightforward. It is stuff that we just learned. I'm not because we learned it at the end. It's just how I ordered the material. I would say that L'Hopital is still going to be there. Limits are definitely going to be there. So Part C says the function h of x satisfies this weird looking function. H of x is x squared minus 4 all over 1 minus the quantity f of x cubed. And we don't know what f of x is, we just know it's some function. Okay, that will work for every value except for when x is 2. This doesn't work when x is 2. We know that the limit as h approaches 2 can be evaluated using L'Hopital's rule. So that's another thing that's really, really important. They're telling us that L'Hopital will work. So I'm going to just put that in here. L'Hopital's rule works. So we want to use the limit as h approaches 2 to find f and to find f prime. Okay, well, if I know that L'Hopital's rule works, then I know that when I do the limit as as x approaches 2 of h of x, that has to either equal 0 over 0 or infinity over infinity. Those are the only two ways that we can use L'Hopital's rule. Well, if I plug in 2 into the numerator, 2 squared minus 4, that's 0. So I know it is not going to be an infinity over infinity case. I know that it's going to be a 0 over 0 case. Cool. Well, if I know that it's a 0 over 0 case, then I know the denominator must be 0 because the numerator is 0. So I can focus now on the denominator, and I can look at 1 minus the quantity f of 2, because I'm going to be plugging in 2 into that cubed. That has to equal 0. Otherwise, L'Hopital's rule would not work. Once I know that, well, I can easily solve for f of 2 then. If I subtract, or if I add f of 2 cubed to both sides, I'll have f of 2 cubed equals 1. I can take the cube root of both sides, and I just found f of 2. F of 2 has to equal 1 in order for L'Hopital's rule to work on this function. So that's the first part. That's the easy part. The next part is challenging. It's not challenging. It's not that you couldn't do it, but it is the harder of the two. So I'm going to continue Part C up here. So one of the things that I have to look at is this fact that we started with, that h of 2 is actually equal to 4. What we know about limits, if a limit exists, it's going to be the same as the function, or it's going to be what the function approaches. And if we have a value, unless it's a piecewise defined function, the limit as x approaches 2 of h of x is going to equal the function value. It's going to equal 4. I know that this is not a piecewise defined function because the problem told us in the beginning that it was differentiable, which means it's continuous. So it's not going to be broken apart. It's not going to have a hole anywhere. So the limit has to equal 4. So knowing that, I can continue on with L'Hopital and continue on with this limit. I know when I plug in 2, I get 0 divided by 0, but this limit needs to equal 4. So if I actually apply L'Hopital to the function, I would be looking at the limit as x approaches 2 of the derivative of the numerator and the derivative of the denominator. Well, the derivative of the numerator, that's just 2x, the derivative of x squared minus 4. The derivative of the denominator, the derivative of 1 is 0. Then we just have negative quantity f of x cubed, so that 3 is going to jump down in front of the parentheses. So we'll have negative 3 times f of x. We're going to subtract 1 from the power, so we're going to square that. But then don't forget the chain rule. We have to multiply by the derivative of f. So we're going to have to multiply by f prime. This limit could still equal 0 over 0, and then we would do L'Hopital again. How do we know we don't do that? Well, we know to evaluate a limit, we plug in that limit. So I would plug in 2. And if I plug in 2 into this, I definitely don't get 0 over 0, because 2 times 2 is not 0. 2 times 2 is not infinity. 2 times 2 is 4. And I know that this limit has to equal 4. And so if I actually plug in 2 into my function now, I have 2 times 2, which is 4, over negative 3 times whatever f of 2 is, I think we know that, squared, times f prime of 2. That has to equal 4. Well, hopefully, logically speaking, that if the left side equals 4 and the right side equals 4, I could write that 4 as a 4 over 1. So hopefully we totally understand then that the negative 3 times f of 2 quantity squared, that should say squared, times f prime of 2 would have to equal 1. It's the only way that the entire function ends up equaling 4. We know f of 2. We were told, we figured out f of 2. F of 2 is equal to 1 right down there. And so if I plug that in, negative 3 times 1 is just negative 3. So this ends up being negative 3 times f prime of 2. And that needs to equal 1. And so that gives us f prime of 2. F prime of 2 must equal negative 1/3. Let's get some points for part C. Point values for part C are as follows. We get 1 point, moving back down here below, 1 point for realizing that let me change that to the correct marker. We know that 1 minus f of 2 cubed equals 1. If we know that, that's going to get us a point. We're going to get a point for figuring out what f of 2 is, the fact that f of 2 equals 1. We are going to get a point for realizing that the actual limit after doing L'Hopital equals 4. And then we are going to get a point for figuring out what f prime of 2 is. That's 4 points. Out of those 4, I could easily see us getting these 2. Getting the first 2 points I don't think is too far of a stretch, and last year my students didn't have many issues there either. So when you look at parts A, B, and C, there's 3, 4, 5, 6 points that are pretty easy. They're not terrible points. They're not hard to come by, and we can easily get those points, I think. Then we get to Part D. Part D, I mentioned this back in the beginning of the school year. Part D used this thing called the sandwich theorem or the squeeze theorem. Not many people liked Part D. It says that g of x and h of x, it's known that g of x is less than h of x, and there's a function k that's in between them. We want to know, is k a continuous function? What the squeeze theorem says is that as long as our functions are continuous, which we know they are, they're both differentiable, which automatically means they're continuous. If their limits are the same, the limit as x approaches 2 of g has to be the same as the limit as x approaches 2 of h. It is, we can see that because they're differentiable functions, they're continuous functions, and their y values are the same. So that has to be true. So, since that is true, we can say by the squeeze theorem, I should use my actual marker, by the squeeze theorem or the sandwich theorem, I know it is the sandwich theorem. By the sandwich theorem, k is continuous. Again, that's because the limits are both equal and k is in between them. And so there you go. Many students did not like that last year. I didn't really cover that last year at all because it's never, ever, ever been on the AP test, but it was only worth a point. So while my students last year came back and whined and complained about that, it was 1 point out of 9, and it really didn't affect them. We had some awesome, awesome scores last year, and I have a feeling we're going to do just as well. I would definitely make sure you know parts A, B, and C, not necessarily Part D, but parts A, B, and C I am confident are going to be on the test this year. So there's the 2019 test. Look for some videos coming soon for 2018. We'll do this for at least a few years, 18, 17, maybe 16, and then that should get you ready for the AP test when that rolls around, and we're going to have information on that April 3rd. That's just in a few days. So until the next video, enjoy, stay safe, stay healthy, stay quarantined, and I hope to see you soon.